Okay, so we're always looking for, how can we use this math in the real world? Where does this come into play? Here's a perfect example of how a system of inequalities could represent something in the real world. Take a look at this business application. A restaurant makes the profits given in the table. So they make $4 on every salad they sell, and they make $2 on every wrap that they sell. The restaurant owner sells at least 100 salads and at least 50 wraps per day. That's like her bare minimum. She wants to earn at least $1,000 in profit a day. Show and describe all the possible combinations of salads and wraps that the restaurant owner needs to sell to meet her goals. List 2 possible combinations. So there's an infinite number of answers to this, but we want to show the area through graphing. We can show all of the solutions, and then we can pick 2 of them just as example solutions, but we'll have the graph to represent all the answers that could really represent the situation. The first thing to do is to write a system of inequalities. We need to take all the key information out of that word problem and make it into a system. Now let's think about what we don't know. We're talking about salads and wraps, and we don't know how many we have of each. There's your 2 variables. Now typically, guys, we question, okay, which one's independent, which one's dependent. But here, salads and wraps, they're really not one doesn't depend on the other. So I'm going to just let X represent salads, and I want you to write that down, and Y represent wraps. So when I go on my graph, I'm going to have salads down on the X-axis, and I'm going to have wraps on the Y-axis. Always define your variable when you start a word problem. Okay, so let's take out some key information here. It says she sells at least 100 salads. At least 100 salads is an inequality in itself. Which inequality symbol does at least mean? Well, at the least, that means at the bare minimum, so she can sell 100 or more salads. Then I'm going to start with X is greater than or equal to 100, right? The number of salads is more than or equal to 100. At the very least, it's 100. Okay, what about this piece? She also sells at least 50 wraps per day. Write an inequality for that. Again, Y is representing wraps. If it's at least 50 wraps, it's going to be greater than or equal to 50. Now, normally we've been working with just 2 equations, but we're going to have a third one here. She wants to earn $1,000, at least $1,000 in profit each day. Okay, so remember that at least, we already know that's going to be greater than or equal to, and she wants to earn $1,000. Okay, what does she make a profit on? She makes a profit $4 per salad and $2 per wrap. That's where this comes into play. So our equation, our inequality to represent that situation would be that 4x plus 2y should be greater than or equal to 1,000. Perfect. So we normally graph in slope-intercept form. The y is greater than or equal to 100, and the x is greater than or equal to 100, and the y is greater than or equal to 50. Those are already, the variable's already isolated, and when there's only one variable, we know that one of those is going to be a vertical line, and one of those is going to be a horizontal line. So the last one we can take the time to solve and get it into slope-intercept form. That means get y by itself. So in order to get this y isolated, you would subtract 4x from both sides. Go ahead and do that with me. And I'm going to write the minus 4x first, and then plus 1,000. And then we would divide by 2. Make sure you divide the entire side by 2. So we get y is greater than or equal to negative 2x plus 500. Perfect. So here's our system. We're ready to graph it. We have 3 inequalities, and we solved the last one down in for slope-intercept form. Okay. Now, taking a look at your graph, I already set it up for you. We're going to count by 100s. We're really counting by 50s on every other line, right? So 50, 150, and so forth. And I put the salads on the X and the wraps on the Y. Now, in order to graph this can get a little tricky when you have a slope that's like -2, but you're counting by 100s or counting by 50s. That's hard. Remember that your slope is always a fraction. This is really -2 over 1. And if you wanted, you could make it a slope that counts by 100s instead. just multiply it by 100. As long as whatever you do to the bottom, you do to the top, you're keeping that fraction equivalent. So it's the same slope as negative 200, positive 100. That's going to be easier to count. All right, perfect. So let's graph. I'm going to start with the pink equation. Let's graph with that third equation. It's greater than or equal to, so that's going to be a solid line. Our y-intercept is 500, so I'm going to go up to 500 and plot that point. From there, I'm moving with the slope of negative 2. It's going to be really hard for me to count negative 2 on this, so instead I'm going to move negative 200 and then 100. So I'm going down 200, 200 over 100. Going down 200 over 100. All right, perfect. I'm going to connect these points. You should ask yourself, do I need arrows on the end of this? You do not need arrows because we cannot have a negative number of wraps or a negative number of salads. So we're going to just stop those right on the x and y axis, but there's your line. Now, to shade this inequality, we said y is greater than or equal to negative 2x plus 500. So where's a point that's greater than that line? It's going to be to the right. If you're not sure, you can pick a point and plug it in. But y is greater than 500 over here, right? Up here. These would be the higher numbers. So I'm shading everywhere on the right side of the line right now. All of these are potential solutions. Okay? Perfect. That's just one inequality though. We have some more to graph. We have 2 more to go. So go back to x is greater than or equal to 100. If you forget if this is a vertical or horizontal line, you can always make a table. We're saying y can be anything, but x is greater than or equal to 100. So go to the x being 100 and put a point there. That means y could be 0, y could be 100, y could be 200, y could be 300. It could be any number as long as it's on this line where x is 0. So there's your line that you're graphing. It's greater than or equal to, so it's going to be a solid line. And again, we don't want to take it into the negatives, so we're just going to keep it going into the we're going to just keep it without arrows. You can put an arrow on the positive side right here, okay? Now for the shading for that one, x is greater than 100. Well, here's an x that's greater than 100. The 200 is. So we want to shade to the right of this line. So now, oops, sorry, I wanted to get a lighter color here. Now this is shaded again. Now take a look at your solution region right now. We have some overlap, right? The solutions to the systems are going to be the overlap of all of the colors. So right now, our solution region is going from here to the positives. It's all of this. We have one more left to graph. We have to graph y is greater than or equal to 50. So let me get my green here. Y is greater than or equal to 50. Again, since you know y could be equal to 50, you could go on the y-axis to 50 and you could plot that point. Y is allowed to be anything greater than or equal to 50, but not less than it. X could be whatever we put with it, so this is a horizontal line. All right, so draw your line. And again, we can have an arrow in the positives, but not into the negatives. There's our line right there. All right, great. And then which way would we shade for that? Y is greater than or equal to 50, so we would be shading above it like this. Now there's a lot of shading in this. So I'm using this, the nice thing about the Promethean board is it gives me a lot of tools that I can show the overlap and I can use different colors. You're going to want to make sure you just shade very gently whenever you're doing this, and then we're going to shade our final solution region to stand out more than the other ones. So where do the 3 shadings overlap? The 3 shadings overlap starting on this line, going along this line, and then going along the top of this line. They are including those lines because they're all solid. So the final solution region is over here. That means all of these ordered pairs, guys, represent solutions to the situation. Now I realize she can't sell part of her salad or part of her wrap, so we're really focusing in on the whole number, the integer values that are in those regions. So give me two solutions. Well, she could sell 300 salads and 200 wraps. That's a solution. She could sell 400 salads and 500 wraps. That's a solution. She could sell, you could even pick a point on this line. She could sell 100 salads and 400 wraps because that is in the shading of all of the regions. So a couple solutions. She could sell 400 salads and 500 wraps. And our ordered pair for that would be 400, 500. Or 300 salads and 200 wraps. You could pick any points in those in that shaded region. So we can see how a system of inequalities can represent a situation to fit all the criteria here for her meeting her goals of making the profit she wants and also selling a minimum amount of wraps and salads that she has. Now you have one to try on your note guide.